This is applying properties of definite integrals. It's actually our second lesson for this unit, but it's called lesson 6.4 because I'm switching the order and skipping some stuff. But so basically, what we started off with is we added up rectangles in order to approximate the areas under the curve. And then if we take the limit of those rectangles and we have an infinite number of them, then they become infinitely small or become a width of going towards zero, then that ends up being what we call integration. And so that's what we're going to talk about. Now, sometimes what we've been doing are functions that were above the x-axis, but sometimes they go below the x-axis. So if the function goes below the x-axis, we're still finding the area between the curve and the x-axis, but if it's under the x-axis, it's negative area. So if you are technically integrating and some are above and some are below, you're going to be adding positives and negatives, and so you can actually get an answer of 0. So if we truly want the area under the curve, we either have to absolute value that, so parts that are underneath, we'll take the absolute value of that, or again, we just have to consider that, okay? So we're just going to have to deal sometimes with negative area. So this is an example of what it means. So if I simply do the integral, I am not truly getting area. I'm getting an answer, a numeric answer, which can be negative. If the entire function is above the x-axis, then the answer will be positive, and it will be the area. But here in this example, I've got some above and some below. So the answer to this integral will be the area above minus the area below. And so, like I said, you can't completely think of this as area, okay? It's not exactly area, it's only area if the entire function is above the x-axis, okay? So important distinction there. Okay, so we have Leibniz notation for how we talk about this summation and how we would write this, okay? So this symbol, integral, is read the definite integral from a to b of f of x with respect to x, okay? Or I usually just say the integral from a to b of f of x dx. That's what this, how you say that, okay? And then they have names, okay, in the different parts. So a is your lower limit of integration, and you always read this, the integral from a to b. We always read lower to higher because that's like reading left to right, okay? So we want to say the lower limit of integration to the upper limit of integration. Now the number a might not be smaller than b, so we'll see that in a minute, but it's still the lower limit of integration and the upper limit. So we always read it from a to b. Okay, so we will always have lower limit a, upper limit b, always say integral from a to b. The symbol itself, okay, so just this right here is called the integral sign, and it's basically an elongated S, because remember, it's really a summation, so it's kind of a stretched out S. That's where it came from. The function inside is called the integrand. And you'll need to know that because sometimes we'll say, especially when you're grading free response, it'll say, you know, you get 1 point if the integrand is right. Well, that means did you get the inside right, okay? And then dx, x is your variable of integration. Remember how we've stressed how important that is. And so we would say the integral of f from a to b, okay? And when you actually do this and find an answer, then we say we have evaluated the integral. Okay, so if a and b are numbers, then generally we will get a number answer. Okay, the definite integral is an area of the region if, again, if f is a continuous and non-negative function. Then this is in fact the area, meaning it's above. okay? So it only works to give us area if the entire function is non-negative, meaning it's above or on the x-axis. Then that is in fact area. Okay, so now we're going to do what is a super very typical problem on the AP Calculus test, okay? It's to deal with things like this where we have to find a bunch of different integrals, okay? So this is the graph. You can see the graph on your paper. So we're going to find a bunch of things. So we're going to find the integral from 0 to 7 of f of x dx. That's how we read that. The integral from 0 to 7 of f of x dx. So we look at our picture. Well, what that's asking me to do is the area between the curve and the x-axis from 0 to 7. Well, that's going to be this right here from 0 to 7. So we want to know what is that area. Well, that area could be found in a couple of different ways. The easiest way here probably would just be to do a trapezoid. So here in the trapezoid, you would have this would be one of your bases, and this upper part would be your other base, because those are the parallel parts. Your height, you can see, because you do perpendicular distance. So we can just do 1/2 height times base 1 plus base 2. So let's go ahead and do that. So we have 1/2 your height. So if we look at our height, again, our height is 4, because that's the up and down part. So 1/2 times 4, get right today. 1/2 times 4 times base 1 plus base 2. So let's go look at those lengths. So we can call this one base 1. It is 3 long, and then of course the bottom one is 7. So we would have 3 plus 7. And so our answer here would be 2 times 10, which would be 20. Okay, so that's the evaluation of the integral. So we just integrated from 0 to 7 of f of x dx. Our answer is 20. We evaluated the integral. Okay, on B, we're going to go from 0 to 13 of f of x dx. We're getting ready to look at properties in a second, but we're going to kind of figure out if they make sense, okay? So if we're going to go from 0 to 13, that means we want that part that we just found. So we want this area right here from 0 to 7, and we also want this part as we go over to 13, because we have to do 0 to 13. Now the thing we have to remember is this one is negative because it is underneath. So we know the area here, this was 20. And let me actually write it in a different color, it'll show up better. So that was 20. Okay, we found that. Now we need to find the area of the blue part, and then we just need to remember it's going to be negative whatever we get, okay? So I'm actually going to just do that right here so that it's a little bit easier to see. So I'm going to do the trapezoid rule again. So I'm going to have 1/2 the height. Well, the height again is, right here. So that height is 3. And then base 1 plus base 2. So we've got 3 for the short base and 1, 2, 3, 4, 5, 6 for the long base. So we end up with 3/2 times 9, which is 27/2, okay, or 13.5. Now, the thing we have to remember is that's the area of that blue shape, but it's underneath. So that means for our purposes, we need to use that as negative, okay? So if we're going to find the area from, or the integral from 0 to 13 of f of x dx, we're going to need the 20 that we found plus the 27/2 we just found, or 13.5, only we have to remember we can't add it, right? Because it's actually negative. So we have to subtract it because that part was underneath. And actually, let me use blue. I guess that makes it match. So that, I colored that in blue, but it's underneath the x-axis, so it's negative. So that gives me 20 minus 27 halves, or 40 halves minus 27 halves, which is 13 halves, or 6.5. So that's what we would say is we evaluated the integral from 0 to 13 of f of x dx. Okay, C. C says let's do the integral from -6 to 0 of f of x dx. So from -6 to 0 means that we want this in here. We want to find that answer. Well, they told us that we have all line segments and a semicircle. Now, we need to find the area of that semicircle. So, of course, the area of a circle is pi r squared. It's a semicircle, so we simply need 1/2 pi r squared. The radius of the circle, be careful, it would be to go from here to here, right? The radius, because the rest of the circle would be up there on the top. So that means my radius is 3 squared. So I'm going to get 9 pi over 2. Now, what's the other thing we have to remember? Well, we have to remember that this is, again, negative because it's underneath. So that means my answer is negative 9 pi over 2. Okay? All right, let's look at D. So D says we're going to go from 3 to 3 of f of x dx. Well, if we go from 3 to 3, so think about how we defined all of this. If we were to integrate this from 3 to 3, well, what's the width of that rectangle? Well, that width is 0 because it's a single point and points have no width. So this area is going to simply be 0. If I integrate from A to A, okay, so 3 to 3, I'm always going to get 0, and that's a property. Okay, now let's go ahead and look at the next two, but I'm going to maybe look over at the properties. Okay, so E, you still say integral from 7 to 0 of f of x dx. Well, the problem is if we go from 7 to 0, we're going this way. So we have a property that says that if you're going from 7 to 0, that's the same as the opposite of the answer going from 0 to 7 of f of x dx. And if we want to find area between the curve and the x-axis, we have to have it in the order smallest to largest. But notice we didn't just flip it. We didn't just say, oh yeah, instead of 7 to 0, I'm just going to call it 0 to 7, because what it does is it gives me the opposite. Okay, so if I flip the limits of integration, my answer is just the opposite. Well, I already found that answer right here, right? So that means my answer here is simply negative 20, because the answer on A was 20, and I'm going 7 to 0 instead of 0 to 7. So it'll be the opposite. Okay, so let's look at F. F says we're going from 10 to 4. Well, we're going to rewrite that integral from 4 to 10 of f of x dx. And also make sure that you are always doing this. You're always writing it lower limit of integration to upper. And you're always saying it that way, because if you start messing around with it, you're going to end up in kind of a mess. Okay, so just telling you, it's always lower to upper. Learn it that way. It'll never get you confused. So if this was the original problem I had to solve, I would simply look at it and say, okay, I've got to find the area from 10 to 4. And then I just have to take the opposite instead of, or so 4 to 10 is what I really need to do. And then take the opposite of the answer that I'm going to get. So let's look at doing 4 to 10. I'm going to use yellow here. I think that will overdo this. Okay, so from 4 to 7 would be this part right here. And then from 7 to 10 would be the rest of this. That would give me the rest of my area to go from 4 to 10. Well, that means I'm going to have to find both of those areas, and then remember that the bottom one is negative because it's underneath, top one's positive, and then deal with the the sign after and when I'm done. So let's find both of these areas, okay? So we again have trapezoids. So this area right here for this upper part is going to be 1/2 the height. The height is 4. Base 1 plus base 2, you got a base that's 1 and a base that's 3. So you're going to get 8 for this area. This one down on the bottom, and I'm actually going to switch to a purple color here. So this one, just remember, it's part of the answer I'm doing, but it's negative, so I have to be careful. So if I were to find this area, I would again get 1/2 the height, which is 3, times base 1 plus base 2. So one base is 2 and one base is 3. So 2 plus 3. So I get 5 times 3 is 15. I get 15/2. Now what I have to remember is that one's negative. Okay. So now go over here and look at what we wrote. So we wrote negative. So just put negative and then brackets. And then just go ahead and put your numbers down. So you're going to have 8 plus negative 15/2. And then the reason that we have negative outside is because we switched the limits of integration. Okay, so if we switch the order for the limits of integration, then that's when we get the opposite of the answer. So adding inside, 8 is 16/2. So 16/2 plus negative 15/2 is 1/2. Then there's a negative out front, so we get negative 1/2. So we have just evaluated the integral from 10 to 4 of f of x dx. Okay, so let's look at g. So g says we're going to go from -8 to 13. So that's all the way across, and the only thing that I have not previously added is this right here, is the -8 to 6. I have not found this area. But otherwise, I found all the other areas, so this will be pretty easy. I just add them all up, remembering the ones on the bottom are negative, okay? So the area of that triangle is going to be 1/2 base times height. Base is 2, and your height is, clearly it's a right triangle here, so your height is 4. So this is going to be 4. So all we're going to do to get the integral from -8 to 13 is we're going to add 4 plus -9/2 plus 20, because that was that whole thing, plus negative of 27/2, because that was that original blue area there. Okay, so that's what we're going to write, and I would write them all down when I have to add a bunch of fractions and things especially. So you're going to have 4 minus 9 pi over 2, because it was negative, plus the 20 minus 27/2. And again, easy to add with fractions, so don't stress over it. Now, a couple of things you can do to make it easier is if you'll add your whole numbers together and then add your fractions together, often that makes it a little bit easier. So -9/2, or it's -9 pi over 2, never mind, I can't do that. So I would have 24 minus 27/2 minus 9 pi over 2. And remember, you can just leave that answer because that's exact, or you can do 24 would be 48/2 minus 27/2, which would be 48 minus 27. Sorry, my brain just blanked. Okay, so it'd be 21/2 minus 9 pi over 2, and just leave that answer. Okay, remember, we don't spend a lot of time simplifying. If it was a calculator question, we wouldn't have been doing any of that. We just put the whole thing in the calculator. Okay, some other questions that are being asked that don't have to do with integration is H. H says, what is f prime of -6? So let's go back to this graph and let's go find -6. So -6 is right here, and they're asking, what is the derivative right there? Well, you have a line segment coming into a circle. So you have a cusp there. So the derivative is undefined. And your reason is basically that your derivative from the left and right are different, or you can say there's a cusp. Just remember on the AP test, you really should say derivative from the left of -6 is not the same as the derivative from the right. Okay, so let's go to the next questions, and then it asks for what is f double prime of 6. Well, f double prime gives me concavity. Well, if we look here at 6, we have a segment. So the derivative would be a constant, because the derivative, the first derivative of that segment would be just a number. It'd be the slope of that line. Then if I take the derivative of a constant, I'm just going to get 0. So that means this is going to equal 0, okay, for that value, because it's going to have a constant there. Okay, J says, find the average rate of change of the function over the interval 0 to 5. Well, average rate of change is irrelevant of the picture. Immediately you know that means the slope. So we have f of 5 minus f of 0 over 5 minus 0. So all I have to do is go find those values. So go back to your graph. This is the graph of f. So f5, if we look at our graph here, f of 5 is right here. So f of 5 is 4. F of 0 is 0. So we're going to have 4 minus 0 on the top. And your 5 minus 0 on the bottom. So you're going to get 4/5. And that is the average rate of change over the interval 0 to 5. Okay. K says, is this true or false? So what do you think? If I integrate from 0 to 2 of f of x dx plus the integral from 2 to 4, should I get the answer that I get from 0 to 4? Well, if I do, this is getting really messy, but if I do 0 to 2 and then 2 to 4, would that in fact be the same as the integral from 0 to 4? And that answer would be yes, okay? And that is in fact a property, okay? And so that is going to be true. Then L says, over which values do we not have derivatives? Okay, so go back to this graph. Now I'm actually going to erase all of this to make it easier to see, because right now it's really hard to see. So you should already have all that written down. But I'm supposed to figure out when is this function, which is called f, right? This is the graph of f. When is it not differentiable? Okay. Well, it's not going to be differentiable here. It's not going to be differentiable here. Not going to be differentiable here. No derivative there. No derivative here, because this slope and this slope are not the same. Okay, so as you come from each side, your derivatives would not be the same. No derivative here, no derivative there. Okay, so there's all of those places. There's no derivative because you have segment connected to a segment that do not have the same slopes, or you have a curve connected to a segment. So my answer would be, it says over which values of x is it not differentiable? And so your answer would be the x values, which would be x equals -6, 0, 2, 5, 7, 8, and 11. And those were all the things that we marked in the picture. Okay. So let's go ahead and look at the properties that we just discovered by the things that we just did, okay? So the definition of the definite integral, if we extend that, here's one of our properties, that if we, f is defined, okay, so we have to have a function there. If we take the integral from a to a of f of x, we're going to get dx, we're going to get 0. Okay, so if I integrate in the same spot. This is another super important one right here, and that is if I'm integrating from b to a of f of x dx, that's the same as the opposite of the answer integrating from a to b, and that's important there. Okay, additive interval property, and this was the last one we looked at, that if I want to integrate from a to b, I can integrate from a to c, someplace in the middle, and add that to the integral from c to b. Okay, so, and I can split that up as many times as I want, okay, as long as they're all connected. Then I can just split it up. Okay, some other properties that we have for different definite integrals. If we have, number 4 says we have a constant times a function, then we can pull the constant out in front. And I'm going to tell you that I am going to do that and do that and do that. We've talked about that before, even with derivatives. If I pull that constant out, it gets it out of my way and makes the problem easier, and you'll see that later. Now, number 5, I want to show you why that totally should make sense. So this says if I'm integrating from a to b of a constant dx. Well, what is the graph of y equals a constant? Well, like y equals 3. That's going to be a horizontal line. So if I want to do the integral from a to b under the curve of a horizontal line, then I'm certainly just going to get whatever this measurement is, k, times that width. So that's what you get. So you get k times b minus a. So we'll look at that graphically sometimes to help us with that too. And then another nice property of integration is that if you are adding or subtracting, you can do each of them separately and then just add or subtract the answer. So if you have a couple of functions being added or subtracted together, like you have a whole polynomial, you just do each part separately. Okay, now we're going to learn quicker ways to do all this, remember, later. Right now we're not doing formulas, right now we're doing the theory and how it works together, because conceptually it's super important for me to be able to go on with that. Okay, so we're going to use the properties of integrals to answer this question. So I don't have a picture or anything, I just have some information. So first bit of information is that if I integrate f of x from a to b, the answer is 8. If I integrate the function from a to b, the function g of x from a to b, I get -3. And then if I integrate the function h of x from a to b, I get 5/2. Okay, so using that information, we're going to answer this question. Okay, so looking at a. Well, a is going from b to a, where what we were given goes from a to b. This is for g. So that means we use the property that says this is the same thing as the opposite of the integral from a to b of g of x dx. Well, we know the value of that because they told us it was -3. So this is negative of -3. This answer is 3. Okay, so that's just using the properties. All right, so B is going to use that property that I said we're going to use all the time, which is that this is a constant being multiplied by the function, so pull the constant in front and integrate from a to b f of x dx. Well, they told me that the integral of f of x dx, if I'm going from a to b, is 8. So this is 2 times 8, which is 16. Okay? Now let's look at C. So C says we're integrating from a to b of 5 dx. So I'm actually going to kind of draw that because I want you to understand, and that'll help us actually answer D in 2 different ways. So if I look at C, I'm going to move these a little bit so I can get a picture here. So if I look at C and I think about what I was saying, is this is telling me to find the area underneath the function called 5, which is just y equals 5. And I'm going to go from A to B, wherever they are. So obviously, it's just going to be a rectangle. The width of the rectangle is B minus A, and the height of the rectangle is 5, because that's where it is. So my answer is just 5 times the quantity B minus A, or 5B minus 5A, you know, whatever. So for D, we could do this in 2 ways. One way is just say, okay, go from A to B of 5 dx plus the integral A to B of g of x dx. And actually, we're just going to do this one way now. I'll show you another way to think about it later that can be kind of helpful. So the last property that we had on there was that if you're adding or subtracting different functions, you just do each of those integrals separately. Well, we just did this one, and this was the answer. And then the integral from a to b of g of x dx was given as -3. So that means this is that plus -3, or of course you can write -3, and that's it. And we can't simplify it really. Okay, so then let's look at these last two. So here we have the integral from a to b of f of x minus h of x. So the property says go ahead and do both of those separately. Okay, and so we have answers for the integral of f of x dx is 8, and the integral of h of x, if we're going from a to b, is 5/2. So this will be 8 plus 5/2. Remember, you can leave that, but if you know your it's minus, didn't pay attention there. So it's 8 minus 5/2. If you're not good at fractions, I would be reducing these as practice. 16/2 minus 5/2 is 11/2. All right, if we look at f, so on f we have the integral from a to 4 of h of x dx plus the integral from 4 to b of h of x dx. So these are the same, which means this is the same as the integral from a to b of h of x dx. And we know from above that that answer is, not -3, that was g, it's 5/2. Okay, that's what you get. So that's using the properties. So when you do your homework, you're going to have a few problems like that that you need to work on. So I'm not going to do this next example. You can do that if you want. I want to look at even and odd real quick, and then that's all we're going to do today. And then we'll talk about those regions in class as a way to kind of go over what we've done. So if f of x is an even function, and we know that when we integrate from 0 to 3, our answer is 8. Okay, so we don't know what the function looks like, and we don't have to know, but we know that it's some function and it's even. And we know if we go from 0 to 3, that this answer right here is 8. Well, if it's an even function and we want to go from -3 to 3, that means you would have just a mirror image over here, right? Because it's an even function. Even functions are symmetrical about the y. So that means this would also be 8. So that means my answer for the integral from -3 to 3 of f of x dx would simply be 8 plus 8, or 16. Okay, if it's even. Now let's think about an odd function, okay? So now we want to take a function that would be odd. Okay, so let's look at something like, let me draw it better here, like x cubed. Okay, so x cubed, if I went from 0 to 3, okay, again, it's saying that this area inside here, let me do a different color to make that not look so messy. Let me try that again. That doesn't look very good. So if I had my, say this was x cubed and there was my integral, and this was 3, and so this was that area, okay? They're telling me that area is 8. Now, because it's an odd function, I'm integrating from -3 to 3, so what would the other part of this look like? Well, remember, if it's odd, you're going to get a mirror image or a reflection or rotation around the origin, reflection about the origin. Or think about x cubed. I always try to think of a simple odd function to help me out. Well, that means if I'm going from -3 to 3, over here I'm going to get the same exact size region, but the difference is this is underneath. So this is going to be negative because it's underneath. So you're going to have a negative portion and a positive portion that are exactly identical, which means the integral from -3 to 3 of f of x dx is going to be 0. Now, that can be super helpful because symmetry can help us out a lot in a lot of different ways. And an odd function going from, -a to a, your answer is always going to be 0 when you do that. Okay? All right. So that's all we're going to cover for now. And like I said, we'll go through and we'll do these other regions and things in class as a way to kind of review and cover a little bit more.